Hello everyone. Let us solve half wave and full wave rectification problems with the help of continuous time Fourier series. So we have first let us do half wave rectifier. As a continuous time Fourier series. Okay, so any periodic signal that we have, let us say that we have a periodic signal that is x of p. Let us say that x of p is a periodic signal and that we want to express as a continuous time Fourier series in the continuous time Fourier series form. So that will be given as, we know that a naught by 2, I'll write it here, plus summation over a n cos n pi t by c. This varies from n is equal to 1 to infinity, and basically bn sine n pi t by c again, and here also n varies from 1 to infinity. Now here c is essentially 2c is the period or fundamental period of x of t. Okay, and the coefficients a naught, a n, and bn are given as, we'll write here 1 by c and multiplied by integral from alpha to alpha plus 2c x of t dt. This is a naught. Value of an is given as 1 by c integral from alpha to alpha plus 2c, and here we have x of t cos n pi t by c dt, and the third thing is our bn, and that is again given by 1 by c alpha to alpha plus 2c integral from alpha to alpha plus 2c x of t sine n pi t by c dt. Here alpha here is our reference point. We have to take a reference point here, and that is precisely what alpha is, and that is up to us to choose. Alpha is up to us to choose. We can choose alpha as per our convenience. So let us solve the half wave rectifier problem. So when I say half wave rectifier, I'll first draw the waveform of a half wave rectifier. So how does a half wave rectifier look? We know that a half wave rectifier looks like, suppose we have, this is the coordinate axis, and essentially half wave rectifier looks something like, if suppose for a input that is sinusoidal, I'm giving a sine input to a half wave rectifier. So the output of the half wave rectifier will look like this. We know that 0 to pi, the positive waveforms will remain there, and the negative waveforms will be clipped in this half wave rectifier. Then we have 3 pi, then we have 4 pi, 5 pi, and so on. Here 0, minus pi, minus 2 pi, and so on. Here this axis is essentially omega t. You know that omega is equal to 2 pi by t, So suppose if we were talking only about the time axis, so this point will essentially be t bar 2, and this point will be t. This point will be 3t bar 2, and this will be 2t, and so on. All these points, corresponding points, the points corresponding to pi will be t by 2, the point corresponding to 2 pi will be t, the point corresponding to 3 pi will be 3 pi by 2, the point corresponding to 4 pi will be 2 pi, and so on. That is on the time axis when we are plotting this graph only for with t. But when we are plotting it with omega t, so this becomes in the form pi, 2 pi, and so on. Because you can see that if we substitute here t by 2 in omega t, if I am substituting small t is equal to t by 2 and omega is 2 pi by t, so essentially this comes out to be pi. And similarly for this point where t is capital T is capital T, and omega is 2 pi by t, so we get this as 2 pi, and so on. Okay, so this is the omega t axis, and this is the output of the half wave rectifier. So how we can basically, this is our x of t. I'll first try to write down x of t. So if I write x of t here, x of t that I will obtain here is, I can write it as a, suppose this amplitude here is a. All these equal amplitudes, these are a. Okay, so this will become a sine omega t for omega t lying between 0 and pi, and this becomes equal to 0 when omega t lies between pi and 2 pi. Okay, so let us assume for simplification, for simplicity in calculations, let us assume that omega t is equal to alpha. If I say omega t is equal to alpha, so I'll form with this assumption, I'll try to form this x of t will become x alpha, and this will be given as, we'll have here a sine alpha, where alpha is greater than or equal to 0 and pi, and when alpha is between pi and 2 pi, we get here 0. Okay. So the first calculation for forming the Fourier series is what we have here is, you might be knowing that we want to calculate the a naught. So what is a naught? We know that this is essentially 1 by c, and here we have alpha, 2 alpha plus 2c. Just take care that this alpha and this alpha are different. So anyway, this alpha is just a reference point, so it will not be a good problem for us. And we have x of t and dt. Okay, so now see here, what is the period of this waveform? You can see what is the fundamental period. The fundamental period is the smallest time period after which this waveform is getting repeated. So you can see that this part and this, then this part and this. Okay, so this is essentially the point where this waveform is repeating. This part, then this part, and so on. But this way, this waveform is getting repeated. So we have 2c is equal to 2 pi. Okay, we have 2c is equal to 2 pi. We have 2c is equal to 2 pi. Okay, so in that sense, the first thing that we have here is we'll have c is equal to, since we have 2c is equal to 2 pi, so therefore we'll have c is equal to pi. That is the first thing with us. The second thing is the reference point, does it alpha. So let us take the reference point, this reference point to be 0. Okay, so a naught can be obtained as, a naught will be obtained as 1 by c, so that is pi, and this is from 0 to 0 plus 2c, so that is 2 pi, and x of here t, x of t becomes x of alpha, and this becomes t of alpha. So we have this, you can see that 1 by pi from 0 to pi, this is a sine alpha, and plus 1 by pi, from pi to 2 pi, we have it as 0. Here it is d alpha, and here it is d alpha. So essentially, we get this as a0 becomes equal to 1 by pi, and a comes outside, so a will be here, and we get only sine alpha d alpha. So that will be minus cos alpha. I will take minus outside. So inside the bracket, we'll only have cos alpha, and this varies from 0 to pi. Okay, this is a0. So this I can calculate it as minus a divided by pi, and we have cos of alpha, that is -1, and cos minus cos of 0, so -1. So this becomes -1 -1, that is -2, and -2 and this -2, 2. So 2a divided by pi, that is our a0. So the first thing that I get here is a0 is equal to 2a divided by pi. Okay, that is the first parameter that we need for our calculation. Okay, now we start with the second parameter, that is what we know as the a of n. We have a of n, and a of n is given as 1 by c alpha to alpha plus 2c, integral of from alpha to alpha plus 2c. Here we have x of t cos n pi t by c dt. Okay, so what are the changes that we see here? The c is pi only here, alpha is 0, and 2c becomes 2 pi, xt becomes x alpha. Okay, cos, here we have c as equal to pi only. So when I substitute c equal to pi, this will become n pi t by pi, and this multiplied by dt. So we get here 1 by pi 0 to 2 pi integral of x of alpha, that is essentially a sine alpha, but that is only from 0 to pi. Okay, so I'll better write here. X of alpha only, and then here I get cos of n t, this becomes n alpha d alpha. Okay, so this becomes equal to 1 by pi. We have integral from 0 to pi now. So from 0 to pi, this is a sine alpha and cos and alpha. And plus I get 1 by pi 0, pi to 2 pi. Within this limit, this is 0 only. So even if it is cos and alpha d alpha, this becomes equal to 0. So we have only 1 by pi a sine alpha cos and alpha. Now this is in the form, I see here that if I multiply 2 and divide here by 2, so this is in the form 2 sine a cos b. So I take a divided by 2 pi outside, and here I get 2 sine a cos b, so that is sine of a plus b. So that is 1 plus n alpha plus sine of a minus b, so that is 1 minus n alpha. Okay, and a comes outside, so we have only this much here. This varies from 0 to 5, and this entire thing here, that is integrated with respect to alpha. Now we have basically Essentially, we have now this thing. We can see that this will be nothing but we have a somebody came. So yeah, so we have a divided by, what is the problem here? Why this is coming very thick? A divided by 2 pi, and we have sine. Now we can see that integral of sine 1 plus n alpha d alpha. So that will be essentially what? That will be cos 1 plus n alpha divided by 1 plus n, and plus cos 1 minus n alpha divided by 1 minus alpha. And this varies from 0 to pi. Okay. So we have here a divided by 2 pi. Now you can see here, we'll just substitute the limits here. So the first limit that we'll substitute it, this will be cos 1 plus n pi divided by 1 plus n plus cos 1 minus n pi divided by 1 minus n, and minus will get, the sine integral is minus cos. So one minus will also come outside. So, and then we have cos of 0, that is 1. So this 1 divided by 1 plus n, and plus that will become minus 1 divided by 1 minus n. This is what we obtain here. So this will be given us now. We can see that if you take this, combine this together, both of them. So what we'll get here is 1 minus n square, and 1 minus n minus 1 minus n plus 1 plus n. So here it will be only 2 minus. Okay. And now here we have cos of 1 plus n pi. In general, whenever we have cos n pi, the general solution for a cos n pi is minus 1 to the power n. So when we'll have cos of 1 plus n pi, so this will be minus 1 to the power 1 plus n. And when we have cos 1 minus n pi, so that time we'll have minus 1 to the power 1 minus n. Okay. This is what we will be having here. So this essentially is this comes out here. Okay. So what we will get here is minus a divided by 2 pi. Here we have here we have minus 1 to the power 1 plus n divided by 1 plus n. And here we'll have plus minus 1 to the power 1 minus n divided by 1 minus n. This is what we obtain here. Okay. So I'm writing this expression only here. We'll get here minus a divided by 2 pi. And now within this, if I take minus 1 to the power 1 plus n common, that I'm taking out common. So what I get here is 1 upon 1 plus n. Okay. And in this part, we'll get minus 1 to the power 2n common. and that is 1 minus n. Okay. So, okay, so we have this minus 1 to the power n here, and then we have two terms here. The first term is 1 by 1 plus n and minus 1 by 1 minus n. We could have written it minus 2 by 1 by minus n square. Anyway, so what we get here is this is essentially minus 2 upon 1 minus n square, and here this bracket closes. So this is essentially what we have here. Now we can see that minus 1 to the power 2n. So minus 1 to the power 2n, that is essentially minus 1 to the power some even number, whatever value, whatever integer value of n we have here, this will always be an even number only. So this will be minus 1 to the power some even number. And so this is going to be equal to 1. So we have basically here minus a divided by 2 pi and a minus 1 to the power 1 plus n, and then we have basically 1 divided by 1 plus n plus 1 divided by 1 minus n and minus 2 divided by 1 minus n square. So this is the thing. Now we can see here that when we have this kind of, this will give us, on the previous page if I see, we have basically minus 1 to the power 1 plus n. So we get here, let us write it a by 2 pi, and I take the minus sign inside. So we get here 2 divided by 1 minus n square, and minus we get here, minus we get here minus 1 to the power 1 plus 2n, and that divided by 1 minus n square. Let me see that if I have written it rightly or not. No. This will be, here it will be 2. Okay, so now we can see here that for all the numbers, for n is equal to, we have here this number, we essentially have this number essentially. So we have, I'm sorry, we have here, on the page was minus 1 plus n multiplied by 2. Okay, so now when we have n is equal to, when we have 1, 3, 5, 7, and so on, for these values, this is essentially our n. We can see that n will be equal to 0. Okay, all right, here n equal to 0, and for n is equal to 0, 2, 4, 6, 8, and so on, we have n is equal to, we have 2 plus 2, 4, a by 2 pi, 1 minus m square. This is how we obtain. So the final Fourier series will be x of t is equal to, we have a naught by 2. So we can see that a naught by 2, we have here a naught is equal to a by pi. So this will come out to be a by pi and plus we have summation of a n. So this is 4a divided by 2 pi 1 minus n square cos, we have here n alpha. So n alpha is essentially omega t. So we have this as omega t. We have alpha is equal to omega t. That is what we had substituted in the beginning. So now n is equal to some even number. Okay, n is equal to 2, 4, 6, and 0 also, 8, and so on. Okay, this is essentially what we obtained here. That is a Fourier series expansion. Fourier series expansion of a half wave rectifier. Okay, so let's stop here. We'll do the Fourier series expansion of a full wave rectifier after some time. Okay, thank you.